Welcome students. Welcome to this lecture. Last lecture we saw about introduction to non-traditional machining process, and this lecture we are going to see about electrical discharge machining part 1. So let's see the contents of the lecture. First one, we are going to see about the origin of electrical discharge machining, that is called EDM. Second one is the principle of working. Third is setup of EDM. So these are the three contents we are going to see in this lecture. Let's see how this electrical discharge machining came into exist. So initially, Joseph Priestley in 1770 first discovered erosive effect of electric discharge on various metals. And it was in this context that EDM was first developed independently in the Soviet Union and United States. And later on, in 1943, BR and NI Lazarenko inadvertently found in their attempt to reduce the erosion of tungsten electrodes that erosion could be controlled when electrodes were immersed in dielectric fluid. Yes, previously John Priestley, he invented the erosion effect of electric discharge on various metals. Later on in 1943, these two scientists found how to control the erection of tungsten electrodes. They found that this erosion could be controlled when these electrodes were immersed in dielectric fluid. And this led to the development of one of the first EDM machines. So in the United States, Jack Beaver, Harold Stark and Victor Harding created an EDM machine in order to remove broken tools from cast aluminum. So this is the origin of the electrical discharge machining. And he is Mr. John Priestley, and these are the two scientists from Russia, BR and NI Lazarenko. Next comes to the introduction to EDM, that is introduction to electric discharge machine. Whenever spark takes place between two electrical contacts, so this is the basic. So whenever sparking takes place between two electric contacts, a small amount of material is removed from each of the contact. Okay, so whenever sparking happen between the two electrical contacts, what happened? The small amount of material is removed from each of the contact. So this fact is used to produce sparks between the tool and workpiece in EDM. And this is the basic fact they used to produce spark between the tool and workpiece in EDM. And it is also known as spark erosion, electroerosion or spark machining. Now let's go to the principle of EDM. So this EDM, electrical discharge machine, works on the principle that heat energy generated by a spark is used to remove material from the workpiece. The tool and workpiece are separated by a small gap called spark gap. The tool and this is the workpiece, which are separated by a small gap, very small gap, and this gap is called as spark gap. And this gap varies from 0.01 mm to 0.5 mm. It means a very small fine gap. The tool and workpiece both are immersed in the dielectric fluid. Okay, so this reaction happened under the dielectric fluid. So when supply is made on, these thousands of sparks are produced per second. When supply is on, that means this negative terminal is connected to the tool is considered as a cathode, and this positive terminal is connected to the workpiece considered as an anode. When the supply is on, thousands of sparks will produce per second. So the duration of each spark is very short. So when the spark comes in contact with the dielectric fluid in the spark gap, the fluid gets ionized. Okay, the dielectric fluid which is present in the spark gap when during the spark is produced, that dielectric fluid gets ionized, so that once it get ionized, it allows the current to flow between the tool and the workpiece. Once when the dielectric get ionized, it will allow that tool and the work, it allow the current to flow between the tool and workpiece, so that a very high temperature of around 10,000 degrees Celsius is generated in the spark region. Okay, so that a very high temperature of around 10,000 degrees Celsius is generated in the spark region. As a result of this high temperature, the material get melted from the workpiece and is removed from the workpiece. These melted particles of the metal are then driven away by the dielectric fluid, and by using the same dielectric fluid which used to drive away the molten metals from the workpiece, so that we'll get the desired shape. Let's see the layout of electrical discharge machining. So this is the tank, and this is the fixture which holds the workpiece, and this is a small pump, and which used to pump the water, pump the dielectric fluid from the tank, and again it used to flush the dielectric fluid in between the tool and the workpiece. So, okay, and we are providing a filter so that it will filter the molten materials, or the machining metal parts which is present in the dielectric fluid, so that the filtered pure dielectric is alone flushed again into the tank. And this is the tool which is connected to the negative terminal, and is called as a cathode, and this is the workpiece is connected to the positive terminal and is called the anode, and this is the servo system which is used to move the tool to and fro. Okay, and this tank is filled with this tank or reservoir is filled with the dielectric fluid. Let's see the setup of EDM. The setup of EDM comprises of four major components. The first one is the tool and workpiece, and the second one is the dielectric fluid, and the third one is the RC circuit and power supply unit. RC circuit means resistance conductance circuit and power supply unit, and the fourth thing is the tool feed mechanism. So this setup of electrical discharge machine comprises of four things. First thing is the tool and workpiece, second is the dielectric fluid system, third is the RC circuit and power supply unit, and fourth is the tool feed mechanism. Let's come to the tool and workpiece concept. So the tool and workpiece is kept in a reservoir. Reservoir means a tank, and is connected to a DC power supply. This tool and workpiece are kept in a reservoir and is connected to a DC power supply. So the tool is connected to the negative terminal so that it becomes cathode, while the workpiece is connected to the positive terminal and it will be considered as a anode. So the workpiece can be mounted on a machine table, with any suitable work holding device like magnetic table, chuck, or any vise or any fixture. Okay, so this workpiece is kept inside the reservoir with the help of any fixture. Now let's come to the dielectric fluid system. This reservoir or tank is filled with dielectric fluid such that the spark gap is immersed in it. The need of the spark gap is so that the spark gap, the dielectric will fill the spark gap, and it will help to flow the current from tool to the workpiece. So the dielectric is continuously flushed into the spark gap. The used dielectric is filtered. So the used dielectric is filtered and recirculated into the reservoir. Okay. The dielectric fluid is pumped at a pressure of 2 kg per centimeter square or less. Now let's see the RC circuit and power supply unit. A RC circuit, or otherwise called as a relaxation circuit, is shown in the figure. This is the relaxation circuit, that is the RC circuit. A resistor R is connected. This is the resistor is connected in series and capacitor is connected in parallel. Okay, the resistor is connected series with the tool and the capacitor is connected parallel with the tool. Okay, so when the supply is made on, the capacitor voltage start rising. So when the supply, if you switch on the supply, the capacitor voltage starts rising continuously. When the capacitor voltage equals the breakdown voltage of dielectric fluid, so this in between tool and workpiece, the dielectric fluid will be there. So when the capacitor voltage equals the breakdown voltage of dielectric fluid, a spark discharge will occur in the spark gap. So when that much breakdown voltage occurs, when the capacitor voltage reaches the breakdown voltage, a spark discharge will occur in the spark gap. So the spark persists until the capacitor voltage falls below that which is required to maintain sparking. Okay, this spark will persist. Persist means this spark will continue until the capacitor voltage falls below that which is required to maintain sparking. If it goes below that the required level, if the capacitor voltage goes below the required level, the spark will cut off. And if the capacitor voltage equal to the breakdown voltage of the dielectric fluid, the spark will produce. Okay, after the capacitor discharge, sparking ceases after the capacitor discharge. Capacitor discharge means once the voltage completely discharged. Completely discharged means completely finished. The sparking ceases. Ceases means stop. The sparking will stop, and the dielectric fluid in the spark gap gets deionized. Okay. When during the electrical supply is happening flow between the tool and workpiece, the dielectric fluid get ionized so that the current will flow through the dielectric fluid. So when the capacitor get discharged and the sparking ceases, the dielectric fluid in the spark gap get deionized. Okay, so it stopped deionized. Deionized means it will reverse from the ionization to the normal stage. Then the capacitor is then recharged and the cycle repeat itself. Okay, so the capacitor recharge and the voltage from the capacitor increases so that it will produce a spark from the tool. And when the capacitor get discharged and there is no voltage increases, the spark also will get stopped, and the flow and the dielectric fluid between the tool and the workpiece get deionized. Here the time taken by the capacitor to recharge again up to the breakdown voltage should be sufficient to allow the dielectric to deionize. Okay, it means how much time the capacitance taken to recharge, that time is enough for the dielectric to get deionized. Now resistance R in the circuit. In the circuit we are providing one resistance in series. This will prevents the charging of capacitor before the spark gap is deionized. Suppose sometimes before the dielectric fluid get deionized, before it get deionized, the capacitor get overcharged, means the problem will arise. In order to reduce that problem, the resistance is provided in series. Okay, so this resistance will control and it will prevent the charging of capacitor before the spark gap get deionized. Now it comes to the tool feed mechanism. Since during operation both the tool and workpiece are eroded. Yes, during this operation This majorly the workpiece will get eroded, and as goes on the tool also will get eroded. So it is necessary to feed the tool, so that it is necessary to feed the tool. Feed the tool means tool has to move or going up towards the or approach towards the workpiece, continuously towards the workpiece, so as to maintain the spark gap. If there is a erosion happen in the tool, means the spark gap will be enlarged, the spark gap will be enlarged, so that the spark will not be produced. In order to maintain the spark gap after the erosion of the tool has to be continuously move towards the workpiece. So this can be achieved by a suitable tool feed control mechanism along with a servo mechanism system. Yes, this servo system and servo mechanism system helps the tool to move forward or move towards the workpiece to maintain the spark gap. Let's see the working animation of EDM, how it is working. Now let's see the real-time working of EDM. How the actual electrical discharge machine is operating in the industries.
आपके ध्यान आकर्षण के लिए क्या आप परिचित हैं इन दृश्यों से? अब देखिए, ड्रिल और टैप ब्रेकेज प्रयोग के समय जब ड्रिल चल रहा था, इस सीएनसी मशीन में तब उसका ड्रिल टूट गया। जब टैपिंग चल रहा था इस टैपिंग मशीन में, तब उसका टैप टूट गया। हमें और आपको पता है कितनी चिंताजनक ये दृश्य है। हो, पर परेशान ना हो, इसके उपाय हमारे पास हैं। विश्व के सबसे छोटा वहनीय किफायती ईडीएम मशीन अब भारत में उपलब्ध है। अब देखिए ये कैसा काम करता है। अब ये इलेक्ट्रोड बेस को लगाइए। अब पावर को फिक्स कीजिए। अब जो जरूरी सेटिंग्स दीजिए अब बाहर के और आने वाली पानी का पाइप को ब्रेकेज पॉइंट के तरफ मोड़े। अब पावर को कनेक्ट कीजिए। ब्रास इलेक्ट्रोड को लगाइए। जैसे आप देख रहे हैं, ये सेटअप तैयार है ब्रेकेज निकालने के लिए। ये पूरा कार्य 10 मिनट के अंदर हो जाएगा। जब हम जरूरी बटन्स चालू करेंगे, तब इसका काम शुरू होगा। और ये सेटअप को अगले जॉब में भी उपयोग कर सकते हैं। हर एक बार एक नई सेटअप की जरूरत नहीं है। बस कुछ ही मिनटों में टूटा टैप हमने निकाल दिया। आप मशीन नहीं, एक उपाय खरीद रहे हैं। अब अंतिम ऑपरेशन में टूटा हुआ टैप, अब कोई परेशानी की बात नहीं। अब आपको महंगा डाइलेक्ट्रिक फ्लूइड्स की जरूरत नहीं, बस नल का पानी काफी है। अब आपको महंगा इलेक्ट्रोलिटिक कॉपर की जरूरत नहीं। ब्रास इलेक्ट्रोड्स का उपयोग करिए। अगर मशीन के लिए काम बड़ा हो तो आप मशीन को काम के पास ले जाइए। ये EDM मशीन आपके ड्रिल और टैप ब्रेकेज को चुटकियों में सुलझा देगा।
Let's see the summary of this lecture. We saw about the origin of electrical discharge machining, then the principle of working of electrical discharge machining, and we saw about the setup of electrical discharge machining. Under the setup, we saw 4 major components are involved in the setup of electrical discharge machining. And this is the reference which I used for this lecture. And thank you, students. We'll see in the next class. We'll see about electrical discharge machining part 2 regarding dielectric and tools, etc. Thank you, students.